Okay, 22nd, 23rd, and these problems are related to the parametric differentiation. Usually, to find the derivative of a function with respect to other, that means derivative of y with respect to x, we need a relation between that y and x. But for these problems, x and y are not directly connected. These two x and y are connected with some other parameter, say t in 22nd problem, as well say theta as a parameter in 23rd problem. For this type of problems, it is not easy to find dy by dx directly. We need to find derivative of y as well as x both with respect to t, and then we need to calculate dy by dx. So first of all, look at this 22nd problem. Okay, x is given like 80 square, y is 280, and here t is a parameter, right? And now for this 22nd, first of all you just try to calculate dy by dt, differentiating y with respect to t. So d by dt of that y is 280. Observe here, a is a constant whereas t is a parameter. So since 2a is a constant, keep it out. So 2a into derivative of t with respect to t is 1, and so dy by dt is 2a. Right? So dy by dt is 2a, and then we need to calculate dx by dt, derivative of x with respect to t. So dx by dt is equals to d by dt of x. What is that x? 80 square. Now look here, a is a constant, t is a parameter. You just collect a out into derivative of t square with respect to t. That is equals to a into, what is the derivative of t square? Derivative of t square is 2t, right? So 2t. So a into 2t is what? 280. And finally, dy by dt is 2a, dx by dt is 280. Now our task is to find dy by dx, right? Dy by dx can be written as dy by dt divided by dx by dt. So that dy by dt is 2a, dx by dt is 280. So simply cancel out that 2a. We left with 1 by t, right? So 1 by t is dy by dx. Okay, have a look.